Welcome to the Data-Driven Manufacturing Podcast, where we explore how data is transforming the manufacturing world. My name is Rowan Easter-Robinson, and I'm an engineer at TrackMyMachines. I'll be talking in every episode to engineers, business owners, and professors who are leading the way in data-driven manufacturing. Let's get started. Hello, Tom. Thank you so much for coming on the podcast. Before we talk about, I'm so excited to have you on. You've got an amazing history from kind of starting at a proper engineering shop, third generation tool making company, all the way through to working with CloudNC, Arrival, Fictive. There's just like so much we've got to talk about today. Before we go into who you are and your background, we're recording this episode here at XY Engineering, which are near Kidderminster, started by a young lad called Jake Bailey and his colleague Sam, and they produce bespoke machinery. They do loads of really good subcontract work. They produce loads of high quality work holding and fixturing for pretty advanced industries like aerospace. Loads of really good stuff. The workshop's really interesting. We just had a really great induction by Annie, who's basically said 100 times, don't go on the shop floor without your safety boots on. So I'm glad the health and safety is top notch in the company as well. And they're letting us use their rooms, their offices for recording this podcast, because between me and Tom, I'm in Sheffield, you're in pretty much Cardiff, right? So this was kind of the halfway house for us. So big thanks to XY Engineering for letting us use the space. Hopefully we will be invited back. I did bring some pan of chocolates just to like smooth that over. So yeah, a little bit of a shout out to XY Engineering. So Thomas, what's your full name actually? Because I see on LinkedIn your one name. Is there a
Thomas David Smith is my name.
I've got you saved as Thomas Parker for some reason. I don't know why.
No, Thomas David Smith, but everybody just calls me Tom.
Tom. Yeah, I definitely. It was just me probably having a bit of a moment. So yeah, Tom. First of all, what got you into engineering?
It was purely accidental. My grandfather started a company when he was 17. So I'm third generation. It's pretty much like everything that my family does. And I've worked in it for as long as I can imagine. It's how I got my pocket money. Like it is how I...
cleaning out swarf bins at 14.
Yeah, driving a forklift at like 12. Deburring parts, polishing, even the money from the vending machine in the actual business. Everything for my pocket money, pretty much oriented.
You're doing the jobs that even the apprentices didn't know.
Yeah, exactly. I think I was becoming an apprentice at like 12. They
were making 12. The teas, you were collecting the money out of the...
Yeah, exactly.
Yeah, it's almost like only children of engineers and children of farmers, the ones who can drive vehicles from an early age. I grew up in Sheffield in a city. I was riding my bike. That was it. It's great to be able to get hands on with big heavy equipment kind of quite early. And now you are chief operations officer, is that right? And also chief product officer.
Yeah, correct.
At Saeki. Who are Saeki and what do you do there?
Yeah, so Saeki are a very young, very future-driven manufacturing business out of Switzerland. Co-founders come from ETH University in Zurich, great robotics background. And while the guys were there, ultimately realized that there wasn't anything in the market for large format additive manufacturing and the benefits of it. So, this is going back a couple of years. You couldn't go buy a Haas machine that done this. You couldn't buy a DMG. CNC machining has got a good foundation for that. Large format printing kind of ends at your 700 mil by 700 mil bounding box. So the guys there pretty much started off building a 3D printer on a KUKA robot. That was ultimately what they started. Print 2 meters by 2 meters by 2 meters. And what they realized was actually producing the parts was a better business for them than actually producing a CNC robotic printer. So they started Saeki, which ultimately is a additive and subtractive company. So they use carbon fiber filled materials, PEI, glass filled materials, print these amazing things for a range of different industries, construction, Formula One, aerospace, defense. And then subtractively machine the critical faces to produce molds and things like that. So it's really quite a niche application. I'd say the biggest challenge is like educating people on what this material can do. A lot of the material is recyclable, so this goes out to precasters who are doing amazing architectural buildings. They cast all their concrete. The molds come back to us. We recycle the material and it goes back into the system again. So we're also saving money in the carbon footprint. The guys there are venture backed because it's the vision is large, scalable, multiple factories. And they needed somebody ultimately who has done this before in manufacturing, who understands operations, who's built factories, and being a very forward-driven, it needs to be a software solution. Whatever problems we have in our Zurich factory, we need to solve it by software so that we can carbon copy that into a factory in Japan, into a factory in America.
You need to copy the business process you developed that hopefully will be super efficient and work perfectly for your style of manufacturing, and then just ship it around the world.
Yeah, exactly. And a problem that I saw, in other areas that I worked is with this same type of model, operations will solve problems. Manufacturing operations are amazing. They will just go down on the shop floor and they will get a problem solved. But more often than not, that problem isn't captured or documented, or you can't take that to another location because somebody else will hit the same problem. So the way that I've kind of fallen into my role is taking my hands-on experience into leading software teams and then scaling manufacturing. So everything I do operationally in Saeki has a kind of software-driven solution behind it. So whatever problems we solve, we try and solve with a software solution. So if it's a quality, if it's a process, if it's quoting, it's ultimately the first solution we try and solve is, can we somehow do this in a process with software so that if we picked up this factory and it went somewhere else, physically it should work, but the knowledge and the actual processes all work as well. We are not going to hit the same problems that, a guy with 30 years experience solved in factory 1, but then in factory 2 in North Carolina, we've got somebody who's only got 5 years experience who's going to struggle with the same problem. So it's ultimately a combination of running the software development team we have and running the operations team and combining those two so that the solution is always, it's not just put on a whiteboard on a shop floor. It's ultimately discussed with a software engineer to be like, this is the problem I hit. Somebody on the shop floor saying, this is how I solved it. And then a software developer understanding that and saying, okay, I'm going to build that into our ERP, our operating system, so that ain't going to happen again in any other location.
Yeah.
And that's pretty much how this role has come about.
Yeah. It's fascinating to imagine that you're trying to build a business that you're trying to skip the 30 years of experiential knowledge that then gets automated after the fact with maybe software consultancy or with a special piece of software. You're trying to do it from day one. And that's what you can do nowadays, I guess, with a greenfield company, is you can try and do the automation from day one. So you set the rules, and those rules are defined not in people's heads, not in hierarchies and, when you put when you finish a batch, always put the pallet here. Just why? Just because that's what we've always done, and it works ever since, day 3, someone forgot where a batch was, and ever since then we've been doing this. There's all these rules that build up in people's heads that you don't realize until you note down the whole business process from quote to invoice. You realize how complex this thing is. But if you formalize it in software, ideally that gives you that ability to make manufacturing scale. And that's one of the hardest things, making hard things, physical things scale.
Yeah.
Software is easy, you just copy paste it. But if you guys can make that work and make the factory replicable everywhere, that's a big challenge to meet and a big challenge to succeed at. I know there's a lot of companies that try and do that. Boeing opened a factory near me in Rotherham in the Advanced Manufacturing Park. And I know that for about 7 years it's been open now. And I know that trying to replicate the factory, I don't know where the factory is. It's in Washington, I think, right? Portland. In the UK, it's not an easy thing. I mean, it's only over the Atlantic. We speak the same language. Imagine if you're trying to open it in Japan or in Germany or in I don't know, Azerbaijan or something. It would be 100 times harder unless you formalize as much as you can in something that is unmodifiable, like a software rule.
Yeah, exactly. And I think the stance that I've always taken, and I think I'm not I'm not a software developer, but coming from a manufacturing operations background, you learn how to work with people, and you learn how to get the best out of people, and having the knowledge of, this is what happens in a manufacturing company. The reasons why you can't machine this way is because of X, Y, Z, this radius, blah, blah, blah. Being able to explain that to a software developer very clearly, makes them excited and very, very fast. So the stance I've ultimately taken is, and the way that, I've kind of grown and built my teams, is that usually within software development, you have a dev team, and then you have like a product manager who owns it. And that product manager is usually somebody who gathers insights from customers and does all this. I've kind of taken that product manager and ultimately got rid of the usual background they have. And I've used experienced special matter experts as product managers. So developing a CAD/CAM system that would automatically do toolpaths. The best product manager for that is somebody who has used a CAD/CAM system for the last 20 years. They can tell you what's good about them, they can tell you what's bad about them, they can tell you exactly what they want, and they can talk to a software developer in the terms of, this is shop talk. And that's amplified, and that's made software development so much quicker, because you're kind of, you're not waiting for a product manager to try and get into a factory to speak to somebody, which is always a painful situation, because, factories are always busy. Nobody's ever sitting around doing anything. Manufacturing's complicated. Trying to explain manufacturing to somebody who doesn't understand manufacturing, who then needs to try and explain it again to software developers, it's like Chinese whispers. It completely changes by the time
you lose the story. You completely lose the story. With something that's as hard yes or no as manufacturing, where the yes is this tiny little goal. It's like trying to aim at the moon or Pluto or something. If you're out by a tiny bit, you are out. Especially with complex manufacturing like aerospace or robotics, making the machinery, producing machinery is some of the most complex engineering you can do on the planet. And if you don't get the processes right, it's going to make it so much harder for the company to produce that machine in an efficient way. And ultimately, if they can't produce it efficiently, it'll be too expensive. You can't survive. So it's a really interesting goal, and it's nice to see that there's still companies starting up producing such difficult machinery, because we all know the CNC machine brands, DMG Mori, Haas, Fanuc obviously making robo drills and loads of control systems. The names have been around for a long time. Admittedly, Fanuc obviously stands out as kind of one of the most automated factories in the world, probably, alongside lots of automotive. So even though Fanuc has been going for a long time, they've got a hyper efficient business. But trying to do that, they've done that through the hard way, through the 50 years of experience and just tweaking stuff. And they got the benefit of making 1,000 robots a month or something. So you've got a lot of volume to play with and muck around processes. So it's really nice to see new companies starting in hardware, because there's a lot of starting in software, and it has been for 10 or 15 years. I mean, TrackMyMachines included as well. And I think there seems to be a bit of a tidal wave that's receding in software, that's pushing actually interest towards hardware again, probably. And that probably leads us maybe to talk a little bit about, you worked at CloudNC and Arrival and Fictive. These are all, you went from kind of working in your dad's shop to real interesting, just pure software companies in manufacturing. And I guess we don't need to go through the whole kind of your whole background, but how important was CloudNC, for example, understanding the trend, how software companies serve manufacturing? Because there's a big problem right now, I think, in software companies serving manufacturing properly. What was the experience of CloudNC like? How did that kind of send you on this trajectory, do you think?
Yeah, CloudNC was my first real experience of a new era of manufacturing driven by a software solution to try and solve a problem. When I first heard about it, I didn't believe it. I've been using CAD/CAM systems for
I didn't either.
For 10 years.
We're going to automate it. That CAD/CAM program is going to be. We're not going to get rid of them. But they'll be doing the job of 4 programmers would be doing.
And I think the realization is that we're never. Probably in my working lifetime, I think it's going to struggle to go from traditional where we are today, everything's manual, to press a button and AI will do everything. And that jump, even for people, is huge and scary. Like, a lot of people still use spreadsheets. A lot of people still use manual drawings and, things like that.
Manual machines.
Yeah, manual machines even.
There's a manual lathe, big long manual lathe.
I know, yeah, and there's awesome cylindrical grinders and surface grinders. I think the step is assistance first, and that's how you get to the full automation.
Still keep a human in the loop. Human still makes the end decision, but just try and shortcut it.
Yeah, take out the redundancy tasks, take out the things that...
like if you've got a 5x part, like a manifold with loads of holes, stepped holes, for example, it's not that hard to that's donkey work. You have to set up all this. Do we need this size drill, that size drill, this boring bar, do a semi-finished cut? It's like, come on.
Yeah.
That kind of stuff should be automatable. There's obviously the hardest thing about CNC machining, especially 5-axis milling, maybe a bit of turning now with mill turns as well, is that the shape can be anything. Someone could have designed a part to be cast or 3D printed, but now they've got to produce it on a bigger scale, or a smaller scale with cast part, a different material, whatever. So the shape can be literally anything. Mm-hmm. Can not be designed for manufacturing. Can be designed for making the programmer's life hell and the machinist's life hell. And that's what CloudNC, I think, will be struggling to perfect. It's the 80% Pareto stuff is probably quite easy.
Yeah.
20% of components that come through the door, it's like, oh, bloody hell, we can't automate that. We need a human in the loop.
Yeah, and it's, how does a system know tolerances? Like, how do I know how you've toleranced that? Because I could design the part exactly the same, but I'll tolerance it completely different.
Yeah.
So how do you inform that? So that's even going back to like design needs to change if you want CAM to change, because not everybody uses the same systems, not everybody tolerances things the same way or correctly, and tolerancing comes through on drawings, and it comes back to what's king, drawing or model.
Yeah.
And if drawing is always king, then AI is going to struggle to work with a model.
Yeah, trying to interpret a 2D drawing is it's going to be difficult.
Yeah,
incorporating kind of the tolerancing in 3D models is becoming more, especially in kind of OEMs down to tier 1 or 2 suppliers. They'll have a standard transfer chain of this is the model, it's in an X, it's got this fit format, you have to just handle it, and that'll be okay. But a lot of companies I know will take a model and they'll produce a 2D drawing from it, even though the customer probably has a 2D drawing, but they're not releasing it.
Yeah.
And so there's all this kind of disconnection and siloed information, all this stuff. Information flow does not cross boundaries a lot of the time. What do you think manufacturers should consider when it comes to, you trying to think about using a product like CloudNC for small to medium manufacturers, which are 80% of the companies in the UK? Is that something they should be exploring now? Are there other options they should look at first? I know it's probably the answer is different for every single company in the country.
Yeah, I think if we look at CNC machining, if you're doing high mix, low volume work, and you use a lot of soft jaws, you use a lot of, fixturing that you also need to machine, I think a solution like CloudNC is ideal because it's, you're running a program if you're doing the soft jaws on something that isn't risking the part at that time. So if you scrap it, you scrap it. That's a bit of a bummer. But fixturing it's I wouldn't say it's no value add to the job, but you don't bill for that.
It's a hidden cost, isn't it?
Yeah,
really?
exactly.
People don't consider that. That's kind of maybe part of the setup time.
Yeah.
Do you bill for that setup time? We had a discussion with the customer last week that was really interesting. It blew up from, oh, how wrong are our setup times to, oh my God, should we be costing for the first off, including a programming time? And then the second time we run that job, should we just take that programming time cost out, or should we have it as extra profit? Or there's all this getting into the economics of the machine, the economics of the business, and the machining time and processes are actually so tightly linked. Yeah. And yet companies have no visibility on those two things. Yeah. I guess we'll touch on more on the economics of machining a little bit later. But I guess when it comes to soft jaws, fixturing, trying to automate, that's the donkey work. That's the ChatGPT style programming work. It's like, we've made a million soft jaws before, just get CloudNC, write the program, stick it in the machine, set your offsets, just press go.
And you need to lower your risk on manufacturing a part and scrapping a part, which, confidence, for a machinist will always come from. He knows where the Zs are, he knows where the tools are going to go. The ideal scenario is that your machinists are able to press go, the machine runs and they go and carry on CAM programming the next part.
Yeah.
If you're asking a machinist to press go and program the next part, but they don't even know how that first one is going to move, or if the bed is going to suddenly turn upwards on a 5-axis, then they've got to stay there with their hand on the feed, which you're paying for it then. Yeah. So I think CloudNC, definitely will get there, and there's others like Toolpath and that.
You need the foundation first.
Exactly.
You need to have the trust a program spat out by your CAD/CAM system.
Yeah.
And trust that your tool setting and work setting procedures, business procedures, are reliable, robust, happen and work every time.
Yeah.
So the ideal is the operator sticks or even you DNC the program in, operator selects main program, go, and walks away.
Yeah.
And they do not look back. It's like dropping a grenade and looking back at the explosion. There is no explosion. No. That grenade, it's fine. Yeah. It's not going to go off.
Yeah, exactly. And I think there's other systems out there that kind of do the same thing with CNC programming, but I'd say are more specialized in production runs. So they ultimately look at the program then that you run every single day, over thousands of parts, and they try and take seconds out of it. They try and maximize, the cut-in of a certain tool just to get that little bit more percentage out of it, which is perhaps, safer because it's just tweaking the program you've already done.
That's the FANUC style of manufacturing optimization.
Yeah.
Bit
by bit, continuous improvement. But, if a manufacturing facility has production quantities, then, congratulations, because that's ultimately where people would love to get to, right? That's money every month, that's continued revenue, that's a safe place. I think the reality is a lot of small to medium manufacturers have high mixture of work.
I think that rather than trying to say, well, we need to chuck away the high mix, try and bring in more volume, is you might end up basically just playing with automotive companies and being a subby to automotive or other companies, other industries like that. And at that point, you're getting really haggled down on price. You might have a contract every year. You have to reduce your costs, reduce your price. So I think the dream of let's just get high volume work, it'll solve all our problems is the grass is always greener thing. And if you instead just get really efficient at doing your high mix stuff with your machine selection, with your procedures, with the way you program a part, release it to the shop floor, you can be a really efficient business and scoop up all that high mix work that no one else wants to do because you're super efficient.
Yeah.
There's always a differentiation. There's always not an opportunity to differentiate. And that's what subbies really struggle with, is differentiation.
Yeah.
And value capture as well. I think in the product, that's another question.
And I think it's about why you get into manufacturing. A lot of manufacturers are some of the most intelligent, complicated problem solvers I've ever met. And if you're telling them they're just going to run the same part every day and press a button, within weeks they'd be bored. They'd be looking for their next job.
Yeah. If you've got good engineers and operators and setters, they are hungry.
Yeah.
And as soon as you let them have a go on the laptop with a bit of CAD/CAM from day one, they'll be like, oh my God, give me a license. But oh my God, it's going to cost me a bit. If we've got Hypermill or something, it's worth it, but it's going to cost us a bit. So I think you're right. You need to, if you get that business efficient in that way, you can give them the interesting work.
Yeah.
And because it's all high mix, it's all loads of programming to do, loads of fixturing, loads of problem solving every single day.
Yeah.
That's stimulating. If you have a high volume shop, you even want it to be even more automated because it has the maximum potential for being boring. Especially imagine there's like a little manual procedure you have to do on this part because it can't be deburred by the machine, this little thing. And someone's got to stand there with a little handy burring tool getting the, oh my God. Yeah.
I know.
That's tough, man.
Yeah.
We've been there-ish. I mean, I've not been working in a shop for a good few years, but yeah, I've had a few days like that where you've just had, 100 parts to your right, 0 parts to your left. You got to put those over there with something in the middle.
Yeah. I've always admired, like my granddad's company is, it's a tool making, but it's also a press shop. So the press shop side of the business is just production parts, every day punching things out. The tool making side of the business is different jobs every day.
So they're doing progressive dies to feed the press shop.
Yeah.
As well as subbing.
EDM. Yeah. And I've always admired, the people who work in the press shop are able to day in, day out, punch the clock, get these parts done at the quality level that means the business is successful and they don't miss anything, but yet they're able to switch off in a way, think about other things, they don't sit there and think, I'm bored or what have you. They're able to concentrate on what they're doing for 8 to 10 hours a day, make sure quality's there, but yet they're able to go to another place that just means they're able to do that. And I've always struggled with that. I've had to do different things and bounce around.
Yeah, it wouldn't fit for kind of restless people like
no, but it's real. I think it's a real skill, and I think when people are talking about skill gaps and shortages, I think even on that side of things, from an experienced operator, having the ability to do that and still make sure quality is right on every part that goes out.
Not get distracted.
Yeah, it's unique, and
treat the job as the important job that it is, and get the job satisfaction out of knowing you made 1,000 parts, 0%.
Yeah,
scrap rate.
And it's one of the hardest jobs to hire for.
Yeah.
You can sit somebody down, CAD programmer, electrician, whatever it may be. You can sit them down with a practical, and you kind of get a sense of how they work. You kind of get a sense of how they think about machining a 5-axis part, and it gives you a really good understanding of their level. How do you call out an operator who can sit there day in, day out, clock in things, making sure quality's right and not switching off, but yet being actively involved in the business? It's one of the hardest roles to hire for. People think it's an entry-level role, but it is one of the hardest things, I think, to get right. And if you get a good group of people like that, then they can make a.
You've got a solid production house.
Yes, yeah,
and you can be reactive. If you've got people like that, you can be reactive.
100%.
I mean, there's a dream. It kind of takes us on to one of your other jobs, your other roles, which was at Fictive, which was producing components almost in like the most automated way possible. What is Fictive? What were you doing there?
Yeah, so Fictive is a marketplace that would produce parts from manufacturers around the world for primarily customers in North America. Fictive didn't move outside of North America. Their customer base was so big there. So a customer would pretty much upload their CAD model, full digital system. It would analyze the part, give design for manufacturer feedback. It would automate the send into manufacturers, but instantly it would give customers a lead time and price instantly. It's the Amazon effect. It's the how younger generations tend to buy things. It's that, oh shit, I need it now. I need to get that part tomorrow.
We're talking like design engineers who are like, oh my god, yeah, I've made a mistake. The lead time, this is on the critical path. I need a component. Just need something in the spreadsheet, so when I go for a Friday afternoon meeting, I can say, yeah, that's coming. It's going to be 6 weeks, or it's going to be 4 weeks, it's going to be 2 weeks.
Yeah, what you tend to find is with the marketplace websites, with there's other similar ones like Exometry, is that the majority of the people who use it are for prototype projects. It's ultimately to get to the stage of we're ready for production, and bringing a product to market. The quicker you can do that, the more chance you've got of knowing that product is going to be successful, that product is not, and it's also a lower cost. If you spread out a vehicle production over 5 years, the accumulation of costs in design and fixing and everything just multiplies. If you bring that down to months, you can get a product out there, you can get it on market. There's
a real benefit for anyone who wanted to get to market as soon as possible. They'd go to Fictive or a few other competitors as well as Xometry. One thing I've struggled to understand is there are subcontractors out there who are desperate for work all the time, have machine capacity right now, will make whatever you want them to make. You can talk to someone on the end of the phone. How can Fictive be competitive when there's, in theory, if it was in the UK, 15 come to my head, 15 subbies come to my head that I could call up today. Hopefully they get a part back by, 2-3 weeks from now. So how can a company like Fictive, a software marketplace, be competitive when I can go straight to the person they're assuming subbing out to? You mentioned they don't have any machinery.
Yeah. So they don't own a machine, the same as their competitors. And it's ultimately the software has made it so easy to buy that it just fits in that wheelhouse. And giving manufacturers feedback on the part they designed actually can't be manufactured. for somebody designing a part, it's quite nice probably to sit behind your desk. You don't have to speak to somebody, and it gives you that feedback. If you call the guy down the road and you give him a part that couldn't actually be machined,
he gives you some crap.
He's going to embarrass you, and he's going to tell you what he thinks of that part.
Maybe that's something you need to hear, though. You know?
Yeah.
Maybe you need a human saying, "Come on, mate. What the hell is this 1 micron tolerance?"
Yeah, absolutely.
300 mil.
But I think that's why when you start talking about production quantities, it does go to that. It goes to relationships, it goes to contract negotiations, it goes to all that. You know, Fictive and their competitors specializing in this stuff just give that instant feedback. And they've ultimately got, they've got a huge database of manufacturers.
And they are doing data-driven manufacturing. They are doing data-driven manufacturing to the max.
Yeah. And they give options to a buyer, right? So if a buyer has got 10 days, 2 weeks, then they can pick the cheapest option, which might be overseas, which, this marketplace kind of takes a responsibility of the quality as well. That is a middleman ultimately, it doesn't just ship work out. Yeah. They automatically take on the responsibility of, so if you as a designer are going down the road and you're speaking to a manufacturer and you're saying, I urgently need this part, please get it for me. You as a designer are taking on the responsibility of the quality then. You're rushing it. If he's done it wrong, it's him and you. That's the only two people in the chain. If you've got a middleman who's ordered your part for you, it comes to you and they're like, yeah, you bought it from us, it's good quality. As a designer, I know who I'm shouting at if that part is bad.
And they've got a big support team and they might have some money to refund you, or they can ship it to someone else.
And they'll get it fixed.
That's interesting.
It takes time. It takes time from me, and it actually takes responsibility away from me as well, which I think is a big thing in a world where we're trying to get products to market. You look at SpaceX, you look at Tesla, you look at Anduril, how quick they bring products to market now. It's not 5 years; it's like months. That speed of being able to just order everything, and something these marketplace to, and what Fictive did. So I was responsible for the software which give you the price, give you the auto quote, and their catalog. So what services did they offer? So CNC machining, sheet metal, 3D printing, injection molding, casting. That's one place you need to go to order all those types of things.
Yeah, whereas you've got to get in touch with the foundry, laser fab shop, CNC subby, maybe you probably go to the 3D labs or something for your 3D printing or whatever. So you already have to, with 3D printing, you kind of already, I know there's Midlands 3D near here, and they do subcontract printing, but I wouldn't know anyone else. There's some areas I think, I'd go to one of those marketplaces anyway.
Yeah.
It's interesting that CNC machining is obviously, it's an old technology, but yeah, we've not had that marketplace. Maybe for 3D printing, the marketplace is the default method of purchase. And maybe it will become the default method of purchase for CNC machining as well. It's just that CNC has the inertia of we've always gone to this, so we down the road.
Yeah.
So that's interesting. Yeah. And do you see companies maybe setting up? Are there a few in the UK? There's one in the UK that have a load of Haas machines. I can't remember who it is though. So I think, it's interesting that model works as well. And designers can lose that sense of responsibility a little bit.
Yeah.
Where there's just you and another human being. When you see this big corporation in front of you, you're like, they can take responsibility.
Yes. Yeah.
Someone will move heaven and earth because it just is in their job description to do it because I'm a customer.
Yeah.
And this is quite nice. Whereas maybe if you go to a subby and then, God forbid, they do make it wrong, they might just go, I'm sorry, mate. Yeah, we just, I've got the apprentice on that day. And, sorry, I can't do anything about it.
Yeah.
Take me to small claims court or something.
Exactly. And it's lead time is another big thing. People will pay to have parts quicker. There's a premium for using these marketplaces. You are paying a lot more for your products,
Do you think there's a detriment to the end user business, the end businesses that are producing the parts though? Do you think they're going to get pushed down on price even more when this marketplace exists as a middleman between them and the customer?
I do, yeah. I think I joined Fictive because I liked the model there. Fictive isn't like we've got a job, whoever's the cheapest gets to take the job, which means that the middleman would make the most money. The Fictive has a very good model where it has X amount of manufacturers it works with, and then the model that we were using and that I was trying to enhance on it was that I knew the best manufacturer to do that part. I could tell you from a CNC part, if a 5-axis machine with 30 tool holder is the best machine to do that part, okay, if I win that part and the customer says, please order for me, I've got a list of the machines that my manufacturers have. So I will send it.
So that's how they did it, not through just a set of names in a bucket. It was to do with the actual introspecting what those companies had on what the capacity was on the shop floor.
Yeah, which for me, morally coming from my granddad's business, kind of, it made more sense to me. It gives the manufacturer the best chance as well, because it's like, we know this is really relevant to you. We know this is something in your wheelhouse. So, you've got more chance of making money on this job. I don't think as a business model in manufacturing, using marketplaces as customers would be a stress-free, easy life. It becomes
the automotive style of
it's unpredictable.
Price is king.
Yeah, it's unpredictable. Lead times are always very, very quick. Like, it's almost, I introduced in Fictive a 1-day lead time for CNC parts. The top customers were ordering parts with 1-day lead time.
And that's shipped from the US. Would they be shipped from overseas as well?
Just US.
Yeah.
So I doubled down on domestic. I wanted to build domestic manufacturing being a big thing. Okay,
I'm sure Trump loves you.
Yeah, I wish. But how could domestic surpass or compete or beat anything else? It's transport.
A pure geographic location.
Yeah, exactly.
And when if you're running a shop, 10 CNCs, and you are eventually competing on these base metrics, like how fast can you get it out? How cheap can you get it to me? You're right, that's not stress-free.
No.
If your only differentiator is your pure geographic locality,
yeah,
maybe no one else is going to start another shop where you are in, the depths of, Ohio or something, or in the mountains in Colorado, but it's a hard thing to compete and differentiate yourself on.
It is, and especially if you haven't set up the shop from there for day one. If you haven't set your shop up to be, CNC, I'll go back to again, but, quick vices in and out. If you've got a clock vices, if you've got a, set up your machines, if you've got a CNC that has minimal tool holder, like, you're not set up to take...
You need the foundations right. It's almost like we talked about CloudNC, or just get your process in place so you can press the button and walk away.
Yeah.
You press the button and walk away first. Then you start speeding up your programming.
Exactly.
The same way, if your setup times are uncontrolled, can vary from an hour to 10, 15 hours, you have a big problem. That's the first thing you need to do as a manufacturer, is control your setup times, especially when you're doing, as most people are, the high mix stuff. Yeah, interesting. So let's hope we don't get moved to the marketplace too quickly, because I think in the UK we have a big problem with lack of automation. We have a big problem with lack of these even just quick setup times. I don't know what the 0 point, for example, what the 0 point adoption in the UK is. That should be a metric we measure, as well as robot density probably, because that would tell, or even just multi-pallet loading machines is a measure of how quick you can be and how much you can run unmanned.
Yeah.
So hopefully the marketplace does not grow that big in the UK. I'm glad you were doing that in the US.
Yeah, well, to be honest with you, the way that things are going and the way, software is going and how quick, affordable and easy it is to do now, I actually believe, and I'm actually seeing, is that the marketplace, they excel on ease of use. It's like Google, right? You go online, you go on Amazon, you drag and drop a part, you order it. That whole interface, that whole solution is being installed now and is being adopted by manufacturers themselves. I've done it with Saeki, I've done it with a couple of other companies where their website has now turned into an order portal. And that's ultimately giving you the ease of use that these marketplaces give you.
But you can control your margins, you control a lot more. You're not beholden to the great fictive in the sky handing you down these orders.
Exactly. And then for the designers, the buyers, if they're cost sensitive, then you're going straight to the manufacturer. You're getting it straight from source. If a part's going to be late, you're going to know immediately because it's the manufacturer telling you. It's not the manufacturer telling somebody else who's then trying to find a solution before they tell you, the designer, and the day before it's delivered, you're then told, it's actually going to be next week. It's coming straight from the manufacturer. You can benefit from, if you've overbought aluminium bars, knock down aluminium price on your portal for X amount of weeks. So I don't think, I think marketplaces will exist because it gives that versatility and it gives you the it gives you the ability to tap into overseas markets, which for some things are, a lot cheaper when you're talking about tooling and, injection molding and stuff. You go to China and it's unbelievably cheap and a good quality. But when you come back to, high tolerance, precision parts, made in the UK or made in the USA, then I really do think for a cheap price now, manufacturers are going to be able to have this portal solution, which also means, for manufacturers, you don't need a salesman. Your salesman becomes, or you add to your sales team by having a portal, by having an online presence and a website that allows people to order stuff direct from you. You can set up preferences, so you only get the parts you want to get. And you come back, you sit by your computer, and there's 10 RFQs ready for you to quote. Or you go a step further and you add auto quote into it, which then increases your possibilities of winning again. So that was a big thing, and I think that is how it's going to develop for manufacturers. It's going to be cheap, it's going to be affordable, and it's going to be tailorable. That's the big thing. It's not like a software guy is going to try and sell you a solution, and you need to get your manufacturing business to fit that software solution. It'll be the ability to tailor it so that I only want these types of parts. I only want XYZ. My payment terms are this, and you can ultimately get that going for relatively cheap now. And with the ability of computational engineering, so like software development, I break into like two things in manufacturing. You have your typical software, they design processes, ERPs, stuff like that. But then you have your computational engineering, which are like different types of software developers, but they specialize in CAD geometry models. They are the guys.
They're like algorithms building models for your, even like mathematical models for like how you quote something.
100%. They are the guys who, they don't build websites, but they're the guys who like analyze a 3D model and can take your tooling thing and
they build the IP really.
Yeah, they honestly
build the value inside the software. The rest is the CRUD.
Yeah.
Create, read, update, which
front
is just when you click a button saying edit, do this, do that. That's your website.
Yeah.
That's not the value. That's just the interface.
Computational engineers are hidden gems in the software world. They really are. And with manufacturing becoming bigger, they are, really coming to light. And the benefit of it is, as an example with Saeki, what we're doing is we get a lot of parts from customers that are the final components, but they want molds. They don't send us a design for a mold. They send us a design for a wing of a drone, and they're like, we need a mold for this. We are now using computational engineers to automatically generate the mold.
Find like the split line. And decide what's clamshell, what even like the inserts, like in terms of which bits can't be molded just with standard.
Exactly. Yeah. So we're using all that now. The first process is like auto quoting. Like computational engineers can design an auto quoter.
Can you do that without knowing what the mold looks like?
We've got like rules that mean that flanges are going to be this length, the standard stock is this length, the density of the material is this. So mathematically, you can get it within a percentage.
If you've got a core, an insert, suddenly you have gears, you have complex fits, you've got that increases the price if I can say that word, non-linearly.
Yeah.
So that might times the price by 1.25.
Yeah.
Rather than just it's an extra bit of volume.
Yeah. And I think it's like this is something that's developing. There's cutting edge companies doing stuff like this. Like there's one in America called Atomic Industries who are doing like amazing things
in the modeling of how you quote something.
Yeah, and the actual making of the mold using 3D printing, metal 3D printing, so that waterways are not straight, they're curved and they go into critical areas.
So you can make the mold smaller if you've not got these straight 90-degree cooling molds. You've got to drill in another place.
And you can actually cool them quicker because the waterways are in specific areas, they're not straight lines.
So if you could incorporate computational fluid dynamics, like a bit of CFD, a bit of simulation, into the design as well, rather than just someone saying, we'll drill this big line and we'll plug it on the other end with a rub screw.
Yeah. So it's all down to risk, right? Like how early do you go to market with something like this? We in Saeki, we've gone quite early because we're very early on. We're a startup. We're prepared to take some risks on costs.
What's interesting is you're producing the machinery and then using the machinery to manufacture almost like your dog fooding is what they call it in the tech industry, where you build a piece of software and then you show someone what you can do with that software or platform by making something with it.
Yeah.
It's like two steps. You're building two businesses almost. It's the
Yeah.
machinery manufacturing and then the component manufacturing with that machinery.
Yeah.
Why are you doing that?
So in Saeki, ultimately, when the business was started, there just wasn't a solution to print. Like we couldn't go and buy.
Are we talking metallic? We're talking just this recyclable material.
So we're just talking about plastics at the moment.
And like filament.
Yeah, filament printing.
So the standard kind of 3D print everyone knows on the desktop.
Yeah, exactly. A massive.
A lot of machine shops have one in the office.
Yeah,
3D printer. I'm like, great.
Yeah, it's ultimately a massive version of that on a KUKA robot. But the extruder, the things that melt the material that feed it.
That's all custom built.
Yeah, that's all custom built in house.
I guess the software to manage the robot, to program it, to send it around, do the toolpath and everything.
Yeah, so there's now good off-the-shelf ones, but they're still very early on. There's still problems. When you're designing for 3D printing, you want to make it as lightweight as possible. You don't want it to be solid. But then where do the structures on the inside go and things like that? So that's what it's like what's
all rule-based with a lot of maths involved.
Yeah, a lot. And a lot of the businesses are still quite early on. And when Saeki started up, there really wasn't a solution. So that's the only option the founders had was we need to build an extruder.
What was their motivation initially? What did they want to build? What did they want to make?
So they just wanted to build
just big things.
A big printer. Like that was pretty much it. It was like
So there wasn't necessarily an underlying need. They just saw that products should be able to be built this big in one piece filament.
Yeah, they were working quite closely with a construction company in Zurich. So
for the concrete molds.
Yeah, for concrete molds, pretty much, which traditionally are done out of wood, carpentry.
Yeah, so you'd hand chisel those out, or you would machine them out with a router?
No, they would create a mold, traditionally with carpentry, with wood paneling.
Okay, so you screw it together.
Yeah, screw it all
almost like you see in automotive in carbon layup. You see people putting those things together.
Exactly.
Beautiful process, really.
It's lovely. It's really, but again, it's such a high skill. Those skills are going as well. So they needed another solution that was, more cost effective, that in 30 years' time could still be used. And ultimately what the guys came up with was we've just done a project called the White Tower in Switzerland. This amazing structure. You can 30, 40 foot tall, and it's all been 3D printed, and the molds are what we done, and then they pour concrete. It's an amazing structure. But ultimately those molds that they needed, the university and the guys, they had a challenge of how do we get big molds that aren't wood. So they said, okay, let's use 3D printing. We can just 3D print the molds. Okay, but they need to be 2 meters by 2 meters by 1.5 meters. And it was like, oh, that doesn't really
exist. And they were shocked, I guess, by the fact that you couldn't find a machine in the whole world that would do a single piece that big.
Yeah, there's definitely things out there, but searchable on the internet, easy access. Be delivered to you in a couple of weeks was like that doesn't really exist. No. So they had access to KUKA robots, seeing what automotive can do with KUKA robots, with machining, with picking up and things like that. It was kind of like, okay, we're robotic engineers. We know how an extruder works. They designed their own extruder, bolted onto a KUKA robot and started printing.
Hey, presto.
Yeah, and that was the start of it. And, the construction industry has really adopted it and seems to get a lot of use out of it. And that's ultimately where, it came to, okay, we need to turn this into a business and try and scale it and see if there's anything there.
So, and I guess the history of what brought you to Saeki, there's a little bit we've not mentioned, which is about talking. You were, I guess, inspired somehow to implement a software system, an ERP system in your family workshop, company, right? And that's kind of led you to Saeki, to working with them to make this amazing, I guess, data-driven, rule-based system from the start. What got you into Saeki? And was it that inspiration to work with your dad's company first and foremost to implement a full ERP system and map out those processes?
Yeah, when I joined, I left school at 16. I went straight into the family business and, learned the ropes, learned everything there is to learn about tool making and manufacturing and, using paper-based quoting on, Excel and a 20-year-old system. And ultimately, still to this day, I see manufacturers who look really, really busy, and yet they can lose money every month. And the reality is in manufacturing, my granddad's business was probably gone through 2 recessions, has survived somehow, hasn't had to let go of people, and has done things a good way. But I do think a lot of what that was down to is just luck. They got good relationships with customers, but
luck in the business sense, but obviously extreme an inherent skill and knowledge and engineering competence and mechanical sympathy. But that's just the basis of an engineering company. The economic side on top of it, I think you're right, is a lot of luck, maybe some good business intuition that no one taught them. They just had to learn on the job. And a bit of a wet finger in the air. How much is that going to cost? Are we going to make money on that? Yeah, well, let's take that job in. There's like the ridiculous amount of skill and knowledge and experience that you need to just be able to produce a component.
Yeah.
But then, the business side, I think, is sadly enough luck of the draw. Can be.
Yeah, and I came to the realization after like 8 years of being there is that the factory can be very, very busy, and we know through history what hourly rate we should run at. But are we going to be profitable month to month? It's kind of like
big question.
We've got some Excel spreadsheets that say that.
Yeah.
There was nothing that was, you couldn't pull a dashboard up and query it. You couldn't say, did we make money on that job? You needed to go and find the data sheets. You
correlate it, pull it all together, and stuff that's lost because it's in someone's head. Timesheets that have been filled in incorrectly or not filled in. And also there's like with accounting, because you're essentially trying to account for that then, aren't you? And you're into the area of accounting, which I used to think was an exact science, but it's not. Accounting's an art.
Yeah.
When you talk to accountants, they're shockingly like, oh, well, we'll just move this number here and do that, and we'll write that off as a tax credit. It's amazing, like how much you can move numbers around to account for different things in different ways. And that's the hardest thing with machining is what's dead time? Yeah. Do you charge for dead time? What's settle time? Do you charge for that? What's programming time? What's fixturing time? We talked a bit about a few of these. Yeah. What did you realize? What did you realize was the biggest problem when trying to account for this in your dad's company?
It's just the fact that the data wasn't accessible. Like I couldn't sit down and be able to tell you exactly where the problems were. You couldn't sit there and say, I know exactly where we need to improve. Everybody looked busy, jobs are going out the door, but we seem to be doing okay. And that I've spoken to so many manufacturers now, ones who've worked with Fictive, CloudNC, running a rival where we had like 2,000 suppliers, speaking to manufacturers, a lot of them still don't know exactly where issues are. They believe they got a good idea, but they're not able to sit down and pinpoint exactly where they should invest more money, where they should not spend time. And I think the most difficult thing sometimes in manufacturing is saying no to stuff, especially if you're not at full capacity. But saying no to stuff can actually save you money sometimes. And that's something that I've learned,
And you need to identify and build up a rule set, which probably a lot of estimators, quote estimators, have in their heads. Because they might over-quote stuff they don't want.
Yeah.
They might, and it's like, well, why? How come that quote's like 3 times that one? It's like the same looking part. It's like, yeah, but we can make that on that machine, but this one, we've got to take a panel off and stick it at the end or whatever. And it's like, no one ever writes that down.
No.
The estimator will just do it and go along the merry way, go home at 5 p.m, go for a pint or a cup of tea or whatever, and no one knows about it. You know? And I find that fascinating that formalizing that it's really hard.
And you're relying on, even quoting is like the first stage. It then enters production. And then through every operation, whether you outsource, subcontract, anodize.
Yeah, lots of different processes, not just the CNC machining, it's all the processes around.
You're relying on having all that information back so that once that job is shipped, you're able to say we made money on it. And you're able to say, we hit our 35%.
And if you're doing stuff like outsourcing for anodizing, for example, if you put 3 products in a batch and then you could just stick another couple on basically for free, how the hell do you account for that? That's where the accounting's fudging the numbers comes in. You just like divide the cost of the anodizing by 5 and times it by 2, then 2 for this and 3. How do you account for all this stuff? And that's where you need to get a bit creative and find nice estimates.
Yeah.
You just say, well, we'll call it that. We'll say all the work we did anodized this month cost us this. Just split it between all the batches that we got anodized, and you get a rough, a good enough figure on a month level. And that's one of the hardest things, because every business is complex. And you were saying to me earlier, every business, basically, there's no single piece of software that works for every business, but it works for almost any. So there's no one piece of software that will work for any business in the world, because they all have their own idiosyncrasies. And is that what you found when you were trying to work through this and figure out how to account for all this stuff?
Yeah, it's almost like you can get something off the shelf and it will improve you. Like if you're starting from zero, it will have its benefits, but they didn't design that solution for you. They don't know how you run your machine. They don't know how your shifts work. They don't know that you've got a quirky thing on your machine that means you've got to do X, Y, Z to be able to get a job out. And everybody needs to have the ability to tailor software. The same way as if you buy a machine, you have the ability to tailor the fixturing, you have the ability to tailor your material rack for inventory because it needs to fit in a certain corner and do whatever. And I think whatever software that is developed for manufacturing has to be tailored by the manufacturers.
You almost want like bring your own algorithms.
Yeah.
If computational models are the value in a business, maybe we shouldn't be telling everyone this. Maybe if the computational models are the value in a business and just a special little way that they do something, a piece of an ERP or an MES that does the quoting for them, does the costing, and lets them run it through the shop floor, that needs to have a module. You stick your kernel.
Yeah.
This is my business kernel. This is the model that we use to quote stuff and run it around the shop floor, and that's our special trick. And maybe something, that's a module that needs to be available.
Yeah, and I think the way that software is going is that is on the horizon. It's not going to be an operating system or an ERP that, fits everybody. It's going to be a software solution that is bare bones, but you can do what you want to it. You don't need...
Bring your own functions.
Yeah, and you don't need a degree in software, and you don't need to pay a contractor or consultant to come in and tailor it for you. Like the worst thing about some manufacturing softwares are they're just black boxes. You're relying on this black box to run your factory that pays for your mortgage and keeps 20 guys employed, and you don't fully know how it works, and you can't tailor it specifically for you. And the way software development is going, and it's becoming more automated and it's becoming ultimately cheaper to develop, I do see a future where there will just be customizable solutions. There'll be software you can buy, there'll be hardware you can buy, and the output is up to you what you want to do with it. It's not, here's the output, this is all we can give you, you have to fit your factory around this. It's ultimately going to give you all the data and all the ability to say, here's everything. Like, what do you want to do with it? Oh, find this job. Did I make money on it? So compare quote versus what was actually done on the machine and be able to see that. Like, why do you want to know that? Oh, because X, Y, Z. I need to make 30% on this because I bought the steel at the wrong time. So I think it's definitely going in that way. Like the startups like Saeki have the advantage of being able to build these in-house with their own software developers. That comes with obviously the financial risk and with the risk that not all these startups are going to survive, but they develop things for the better good. But I do think that there is going to be...
It's going to trickle down to the SME level.
Yeah, that's the things that we innovate on trickle down. Companies can take all these risks and they try and develop something that may work, may not work. If it does work, it'll trickle down somehow. It'll come through your packages in Fusion. It'll come through, other solutions. It will come down and be affordable to mom and pop shops and people who really need it, because that's the bread and butter and that's everything. But I do think that the software solutions of tomorrow are going to be, here's the basis, you tailor what you want, you put into it exactly how your business runs. And that's the way I think, I've been lucky enough to run teams where I've put the special matter experts in charge of the software, because they're the ones who can then
They want to be the inmates need to run the asylum.
Yeah,
I'm sorry, you're not inmates, all you engineers out there.
Yeah,
close enough.
but they're able to say, this is what I wanted to do. I've struggled for years on this software doing this. This is what I want this software to do, and they can relate to any CAM programmer. They can relate to any grinder, or they can relate to anybody to say, like, I'm solving that problem. And I think that is definitely the way it's going. And I think, even with your hardware solution, I think that having the data available is critical to businesses, but they will all use it differently.
And that's one thing. The best software solutions to run a factory and make the factory operations as introspectable, as transparent as possible, have all been bespoke.
Yeah.
There's a company in Attercliffe. It's just been bought out by an Italian company. They have an in-house software developer, and they've had a system that's been honed over 25 years, and it's amazing. They're quite easy to band. They do material supply, so it's all bandsaw stuff. There's not that much complexity, but they have everything is just down to the second. They still brought me in because they didn't connect to the machines. They didn't know exactly. They were pretty sure, like 90% confidence, that the machinery was running at about 85% utilization, which is great, absolutely amazing. But they wanted to bring TMM in just so they could monitor what the machines were doing exactly. But the way they ran the MES, the ERP side, where the material was, how they run it, where is it going, what's next, all the projections as well. Planning is really hard. Knowing what happened is hard, but planning ahead is even harder when you have incomplete information, as most manufacturers do. These guys were the best I've seen. It helps that they were only doing bandsawing. They had a couple of maybe 6 band saws and a couple of those circular saws, which are a bit quicker, So they had the multipliers down for if it's on the circular saw, it's going to be less than this max diameter, but we can do it this times faster. All those little numbers were down and were perfect. But that's like such a tiny subset of what you can do on a CNC machine.
Yeah. So, but I bet they use your solution completely different to another customer.
Completely. That's why I think with TMM, I'm 4 years in, I still struggle kind of to know when someone says, what should I use it for? I kind of don't really know. I've come up to the conclusion there's kind of 3 major things you'd use it for now. But when I started, I just said, well, let's just get as much visible as possible on a screen and see what people use it for.
Yeah.
And depending on the production pressures, the way they run the factory, people use it completely differently. There's a composite door manufacturer who've boosted productivity by a quarter just because they changed the way they measured the output. At the end of the day, they went from units to machine hours up. And as soon as they went from units to machine hours up, bang, productivity improved 26% because they were just using it for pure factory capacity measurement. How long were machines using? What is the percentage of the time and shift I'm using my machines? And that's because they were planning in for, we think a door takes 10 minutes a piece. We can do, 200 doors in a shift, whatever. As soon as they went to, we just want to maximize the use of the machine, we can now make 250 doors. Just simply changing the mindset and measuring the machine utilization, changing the metric. Other companies, they're religiously capturing the reasons for downtime. And that means that once you get a reason for downtime, whether it be setting up the work, setting up the tooling, changing tool packages, doing first off inspection, you have a number for how much did setting up the work cost you in the last month.
Yeah.
Per machine or per shift pattern or whatever. But it's just a big fat number saying 300 hours for setting up work. Multiply it by a machine hourly rate, 18 grand, let's say. You now have a number where if you want to go and cost up investment in work holding, and you can estimate if this saves me 20% in time on the work setting, how was the ROI? You can do a quick notebook calc and figure out what the ROI is for 0 point like that. If you didn't capture that data, you couldn't do that case study, you couldn't figure it out. So, and these are things, and I thought, well, as soon as you measure the utilization and capture a downtime reason, you know exactly what to do on the shop floor that day. You don't.
No.
You can't go from the what is to what you ought to do.
Yeah.
That's the big problem in science and data capture. To go from this coffee is 35 degrees, what should I do? Oh, well, I know I've got to go and put it in the microwave, but science can't tell you.
Yeah.
You know? So measuring this, I'm still figuring out what the use is in measuring this data, you know. But those are two big benefits, and you only see it when you work with customers. And you're right, every single customer they use, and that's why you need a kind of like a generic system, but it needs to be generic enough that you see what you need, and you might only use 10% of it, but it still has a value as a system, you know. It's just you don't know which 10%. It's like marketing; you don't know which half of your budget is actually useful.
Yeah.
So that's useful. And this year, the big push for me is talking to more machines and being able to get as close to that direct accounting as possible. Is I want to be able to type into a chat box, what were the 10 jobs I made the most money on last month?
Yeah.
What were the 10 jobs I made the least amount of money on last month? Then that tells you, that's the closest I can probably get customers to knowing what to do.
Yeah.
That's probably a great example. But hopefully I can build the tools in a nice enough user experience, in that it's as less of a black box as possible, that they can, it's like with a spanner, you can go and use it on an adjustable wrench, you can go use it on as many different sizes of nut you can, you know how it works. If you try and make a software as transparent and intuitive as possible, hopefully they'll find a way to use a tool that I never thought of.
Yeah.
I never thought of telling someone to go from units to hours in their cultural mindset on the metric. I never thought of that, but they did because that's what they could see.
Yeah, that's how they work.
Yeah,
and that's how they think. Yeah, it's like I was saying. I think if somebody delivers a full tailored software solution into manufacturing, and they, it will definitely help, and it can definitely improve stuff.
But is tailoring needed if you've got, let's say, two systems that can work together? So one customer has an ERP called Progress Plus. We're talking about integrating just so they can automate inserting the timesheets.
Yeah.
Just because they got guys spending 15 minutes, and there's 29 machines, maybe 25 people, all spending 15 minutes a day inserting timesheets. With TMM, we know how long the machine's running, so we just insert that time instead. With a couple of API endpoints and a reasonably robust batch job or something, you can automate that. So I think there's still a lot of value in, if the systems are open enough to talk to each other, they don't need to necessarily be tailored. You just need a little bit of glue code in the middle that can pull the operational data from the machine tool and use that to automate stuff in your ERP that has no idea what a machine even is. So I think systems being open and then tailoring the edges might be another option.
Yeah.
But I think that's always a stopgap. I think you're right that eventually, hopefully, every SME will have their own branded ERP, MES, all single dancing thing that fits them perfectly. All their little idiosyncrasies. The boss wants everyone to clock off at 3:59 on a Friday automatically and get them an ice cream ordered to their front door or whatever. They can do it. And that's the dream.
Yeah, and it is. And I think getting to a point where you can predict planning, predict financial models, be able to say, if I win this job, I know we're going to do X, Y, Z. Being able to say, should I buy that new machine? If so, what jobs do I need to win? Which is unique to every company, because some companies own their machines, some companies lease machines. It's so unique. And I think that's the really exciting thing about manufacturing. I think there's definitely been, in the last 12 months, I've never seen so much keen investment from the VC side of the climate, where venture capital businesses are looking to get involved in companies. Traditionally, it has been very software heavy. It went through the crypto boom and it went through all of this. We are definitely in a stage where manufacturing is coming to that forefront now.
What do you think the big business is to watch
with regards to
new startups in manufacturing?
Oh, that's a good
present
one.
Company accepted.
Saeki is very unique. Saeki's got a very...
It's probably quite unique in Europe as well, because Europe is not known for startups. We are. I'm going to include the UK in Europe. Just aspirationally. That we're not known for innovation. We've been a bit of, or Europe mainland more so, but we've been a bit of a general large scale decline for a long time, and kind of propped up by Germany's manufacturing base and various other things. But the US is, all the top talent will just flee to the US as soon as they have a good idea, basically, because the scale of investment you can acquire, whether that be rightly or wrongly, whether you're just selling some snake or whatever. It just means that basically all the talent almost around the world goes to the US. So I guess Saeki are a bit of bucking the trend a little bit. Are there any others you think that buck the trend in Europe, in Switzerland, in the UK?
There's one in Germany. They're doing CNC machining. Dilust, I think they're called.
Dilust.
Yeah. The co-founder was one of the original software developers of OpenAI, I believe. He's very much gone down the CNC route, partnered with DMG Mori. They are
they doing the digital twin?
I believe so.
Yeah,
but
I think I met them maybe.
They are manufacturing parts. I believe they've got the same model as what Hadrian has in America, which is high-end manufactured parts in quick lead times. So they're interesting. They again have got challenges ahead of them, like anybody. Any VC-driven company within manufacturing has like big challenges, especially if you're producing components. Like if you're building the end product, then you've got a much higher revenue. You look at Anduril, for instance.
Yeah, they capture the value in the product.
Yeah, they build a product and then they sell that product. They manufacture that product and things for it.
I was in a subby, I can't remember, in the Northwest, and they made a lot of transmission components for a tiny little place. I don't know, 6 Hercos, like just a little subby, low ceilings, a few old guys with the blue jackets on, and they were making these transmission components for this like hypercar. There's 100 off. They maybe it's just like 20 off or something every year. And I looked online and they showed me the website of these cars, and I'm like, oh man, how much that cost? Like, it's probably like $500,000 or $750,000. And like I said to him, if you imagine what the value of that component is inside that car, it's like probably 25 grand or something, all those components together. I'm like, and I bet you like capture 10% of that value, it's even less than that, So subbies capturing the value of what they produce is just impossible. Because you're in a competitive market. If you make the product, you're differentiated, someone needs to buy it, you can charge whatever you want. You capture all the value that someone has. But even if you're making stuff for planes, your only differentiability is in how complex the process is and how much pain and suffering you're willing to go through to make it for them. That's the hardest thing.
I think there's a lot of companies in Europe that are, really pushing the boundaries of manufacturing and doing very successful. You just don't hear about them.
No, I was going to say.
We don't have the coverage like America. No. We don't have the PR. We don't have the marketing. We don't, I'd say 70% of manufacturers in the UK don't even have a website.
Yeah.
That is the reality of it. Some of the mom and pop shops are doing the most complex, amazing jobs. You'll never ever, you could drive past them down the industrial estate and you wouldn't know.
It's amazing, isn't it, really?
Yeah, so it's, they're the real heroes. The VC-driven startups in manufacturing you tend to hear about more because
they've got the money to put into the budget, haven't they?
It's marketing, it's hype. But what comes with that is the reality of risk. Like if you aren't 10x in year on year, that you struggle to survive in those businesses.
It's a real just live or die scenario, and you can't just grow slowly, organically, take it easy.
No,
you have to go crazy, and if the bubble doesn't, if the explosion doesn't happen in the first 3 years, you're gone. Whereas what might have been a good idea in the kernel can become, I think, corrupted a bit by the fact you have to just go crazy. You might not have found the right product market fit. You might not find even the right messaging. Like with TMM, it's taken me 4 years to even realize why someone should use the product. And if you don't find that in the first 1 or 2 years, then you've got quite a large risk you're taking.
Yeah, 100%. I think Arrival was my biggest learning of that. I joined Arrival and I had a beanbag in a factory hall, and in like 12 months it needed to produce 10,000 vans. Like that was it. There wasn't a hole in the ground. It was just, and
so the expectation is huge.
Yeah, the expectation is huge.
Pressure does make people perform. It makes companies perform.
It does.
Can be good.
Yeah, it does. But sometimes, when you have development cycles and things like that, we were building the factory and the final design of the vehicle hadn't been finished. So we were building the factory to build
without
vans,
knowing the exact
without knowing
layout.
Exactly what the van would need. And Arrival is like one of my biggest learnings, and it's one of my greatest experiences. That company grew exponentially. The talent there was incredible. I've never seen so many now founders start in manufacturing come from a business like Arrival, because it just give everybody the encouragement that you can do this, like you can go and do this. We were doing things that I'd never seen been done before. We were producing the panels for the van out of composite material in the factory. We were producing the van, like our supply chain was there. We were growing end on end. I had the factory in Bicester, was staffing it up, was putting all the cells in, was doing all that. And we were working on a van, we were working on a bus, we were working on all these other things. We were, I'd say, lucky and unlucky. Lucky in the fact of there was a big boom around the EV car market. So, Arrival IPO'd at a huge amount of money. But in doing that, it makes everything in the business like urgent and go quicker and transparent. Like if you say you're going to do something, now you're on the public market, you have to do it. And the reality of trying to develop a product that quick is that it just couldn't quite get there. But stripping back from that, we had AMRs there that were Arrival AMRs driving around the facility. Like on their own, that is one of the best products I've ever seen. Never mind the vehicles, that's one of the best products I've ever seen. The composite paneling that we put on the vans were incredible. It didn't need paint. It didn't need...
It came out the right colour, the right finish, the right fit and flush.
Damage. You could hit it with a hammer and it would not damage. So for logistics, it was
I need that for my van. Unless I'm hitting bollard.
Yeah. So for logistics, it was perfect. But being that backed company means that you've got to go so fast that it ultimately meant that we just couldn't get to where we needed to be by certain things.
Is there another option though? There isn't really. If you need to produce a physical object, you need a factory, you need capital.
Yeah.
Is there another option? There isn't really, is there? If you're trying to produce something as complex as a car,
no,
without being Bernie Ecclestone, or just a billionaire.
Exactly. I think for anybody who's starting up, if we go on the lower scale, starting up like a manufacturing company, there is brilliant terms out there now for leasing machines. You don't have to go out and say, here's 250 grand for the CNC I need. It might be 7 grand a month. And, maybe you can afford that. But, everybody in manufacturing, I think, who runs a manufacturing company, who owns a manufacturing company, has put their whole life at risk from day one.
Yeah, like Jake and Sam here at XY.
They've remortgaged their house. They haven't gone on the holidays. They've really done it because they want to get something off the ground, and it's been invaluable to them. Those guys then can't go spend 100K on having a software developer develop the solution for it. But the way I see these well-funded manufacturing startups is they can do that. And they may not be successful, but there will be things that trickle out from it. Like Arrival split up into many, many different things, and parts of the business have gone elsewhere and done amazing things for other companies. And that is generally, a benefit and what can happen. So
it's kind of the joy, some of the joy in capitalism is that you can raise loads of money and not be tied to your name. You have a limited company. Maybe you do loads of crazy stuff, spend it all, go bust. But loads of people have learned a huge amount from that. That nobody took any necessary personal risk.
Yeah.
Or maybe a couple of people mortgage their houses. The founders or whatever.
Yeah.
And they're the ones taking the largest risk, but they have the largest potential rewards. So that kind of makes sense, and they're recompensed in the expected value. So at the end of the day, a company going bust is not a bad thing.
No, definitely not.
It's almost like you've fallen, you've tripped over. Just learn from your mistakes. And that's how we all benefit in the long run as a society. It's because companies, some visionaries take the risk, fall over, or do it, make it big, and then we get a better van out of it. Or we don't, but people have learned how to make better AMRs.
Yeah, exactly.
And that helps something else.
Yeah, I'm able to finance computational engineers to do R&D. I'm able to finance a computational engineering team to try and generate a mold tool from a part that we really need to get working and want to get working, but if something happens to the business in 2 to 4 years' time, those computational engineers have all that knowledge of how they've done it. So if they go and work for Fusion, Hypermill, CAD/CAM package, or something that's already in the market, they come in with that knowledge of, oh, I know how to do that. And it's like, great, share it. Like that is the biggest thing. And
and that's the thing, as long as the company invests that money wisely into producing something that the market can use. Does not into a product necessarily, because the product might be crap, might be a flying pen. No one needs that. So the knowledge in making that is probably not. It could be useful, but not that useful. If as long as your operations every day in that finance-backed company are always focused around a customer in mind and a market, someone to help, then that experience is not wasted.
No, I think it's benefiting manufacturing as a whole. It's mom and pop shops can't take the risks. It's fine lines between profit and loss, and that is manufacturing. That is, it's one of the most difficult industries to be profitable in and successful in. It's one of the most rewarding as well. So you've kind of got to rely on other people to innovate and take risks. If you do have the luxury of being able to innovate internally, then amazing. Like, all the better. If you can hire 10 more apprentices, like, that's success. If you can train apprentices, if you can bring people through because you are innovating and you are able to make your margins, then, in manufacturing, that is, for me, like, success.
Yeah. Perfect. I think that's you set the world to rights now, Tom. That's it. Thank you. Manufacturing being the most difficult, what you said, the most difficult, but the most rewarding. I'm glad you added that bit, because you were like, it's difficult, it's hard, it's impossible. Oh my God, you have to mortgage your house. But it is a really satisfying thing to be in. It's a really satisfying industry. And at the end of the day, it makes everything we see around us and we use to live, basically.
Yeah. And I think only now it's coming to light how important it is to, communities, countries, livelihoods, jobs. The fact that we need to make stuff, is becoming really forefront and center of it. And I think if you speak to anybody who's been in manufacturing, if you say to them, "Oh, would you like a job in fintech or banking?" they'd be like, they go stir crazy.
Like, what am I going to be working with that I can see every day?
Exactly.
Oh, well, if you turn the monitor off, it goes away.
Okay,
well, no, thank you. And let's hope that manufacturing, nowadays, let's hope manufacturing kind of is a reason to bring countries together, not for them to split apart as well. Because obviously there's a lot on the global scale that's quite worrying about when the manufacturing happens, where it gets bought, and hopefully we can keep those skills in-house.
Yeah. I think
the country level.
Yeah, I think there's always going to be the price competitive. You can get it cheaper elsewhere. But there's always going to be, whether it's defense, security, whether it's just the pride of, made in the UK or made in America or made in Italy, whatever it is. There's always that comes along with it. But, I think the reality is that just some countries are better at some things. You go to certain countries for aerospace parts. You will go to certain countries for a plastic part, because they become experts in it. And everybody should, hopefully benefit from that, and hopefully that's what we'll see over the next 5 to 10 years. Yeah.
Brilliant. Thank you so much, Tom. It's been fantastic. And thank you for listening to the Data Driven Manufacturing Podcast. We've been hearing from XY Engineering in Kidderminster. One last plug for the guys who've let us use their Ian Jones's office. Thank you, Ian. Really appreciate it. So as Jacob and Sam started this company, XY Engineering, they do loads of bespoke fixturing, bespoke work holding, bespoke machinery, really cool stuff. They're growing. They've just got a brand new Haas UMC 1250. I've just seen it. It's a really nice machine. It's got chips all over it. They're using it every day. It's good to see. So check out XY Engineering if you need any bespoke work holding, I'm talking like complex hydraulic fixturing. Really cool stuff. And thanks again, Tom, for coming all the way from Cardiff.
Thank you. It's been a pleasure.
You've set the world to rights now, Tom. That's it. Thank you. Manufacturing being the most difficult, what do you say? The most difficult, but the most rewarding. I'm glad you added that bit because you were like, it's difficult, it's hard, it's impossible. Yeah. Oh my God, you have to mortgage your house. But it is a really satisfying thing to be in. It's a really satisfying industry. And at the end of the day, it makes everything we see around us and we use to live, basically.
Yeah. And I think only now it's coming to light how important it is to, communities, countries, livelihoods, jobs. The fact that we need to make stuff, is becoming really forefront and center of it. And I think if you speak to anybody who's been in manufacturing, if you say to them, "Oh, would you like a job in fintech or banking?" They'd be like, "No, they go stir crazy."
Yeah. What am I going to be working with that I can see every day?
Exactly.
Oh well, if you turn the monitor off, it goes away.
Yeah.
Okay. Well, no, thank you. And let's hope that manufacturing, nowadays, let's hope manufacturing kind of is a reason to bring countries together, not for them to split apart as well. Because obviously there's a lot on the global scale that's quite worrying about where the manufacturing happens, where it gets bought, and hopefully we can keep those skills in-house.
Yeah. I think
country level.
Yeah, I think there's always going to be the price competitive. You can get it cheaper elsewhere. But there's always going to be, whether it's defense, security, whether it's just the pride of, made in the UK or made in America or made in Italy, whatever it is. There's always that comes along with it. But, I think the reality is that just some countries are better at some things.
I'm 4 years in, I still struggle kind of to know when someone says, what should I use it for? I kind of don't really know. I've come up to the conclusion there's kind of 3 major things you'd use it for now. But when I started, I just said, well, let's just get as much visible as possible on a screen and see what people use it for.
Yeah.
And depending on the production pressures, the way they run the factory, people use it completely differently. There's a composite door manufacturer who've boosted productivity by a quarter just because they changed the way they measured the output at the end of the day. They went from units to machine hours up. And as soon as they went from units to machine hours up, bang, productivity improved 26% because they were just using it for pure factory capacity measurement. How long were my machines using? What is the percentage of the time and shift I'm using my machines? And that's because they were planning in for, we think a door takes 10 minutes a piece. We can do, 200 doors in a shift, whatever. As soon as they went to, we just want to maximize the use of the machine, we can now make 250 doors. Just simply changing the mindset and measuring the machine utilization, changing the metric. Other companies, they're religiously capturing the reasons for downtime. And that means that once you get a reason for downtime, whether it be setting up the work, setting up the tooling, changing tool packages, doing first off inspection, you have a number for how much did setting up the work cost you in the last month.
Yeah.
Per machine or per shift pattern or whatever. But it's just a big fat number saying 300 hours for setting up work. Multiply it by a machine hourly rate, 18 grand, let's say. You now have a number where if you want to go and cost up investment in work holding, and you can estimate if this saves me 20% in time on the work setting, how was the ROI? You can do a quick notebook calc and figure out what the ROI is for 0 point like that. If you didn't capture that data, you couldn't do that case study, you couldn't figure it out.